Good morning, dear students. I am Dr. Paresh Rawat. We are here again for the control system lab, the experiment number 7. Now, here in previous experiments, we have already seen body plots and the root locus methods of calculating the stability analysis. Here in this particular experiment, the title is to determination of the Nyquist plot using the MATLAB control system toolbox. We will be using a control system toolbox for determination of Nyquist plot. The objective of this particular experiment is to determine Nyquist plot of a 2D second order control system. Now the second order control system needs to have a certain transfer function. We have already discussed the theory part in the classes. The basic closed loop control system look like Ts is equal to 1 Gs upon 1 plus GHSS. GH is the open loop gain system transfer function and HS is the closed loop transfer function. So this is the overall closed loop transfer function system which we have actually. Now here during the basically Nyquist plot consideration, we will be considering the denominator of part, which is a complex function ds is equal to 1 plus GHSS. Now from this 1 plus GHSS, I have to satisfy this, that is number of poles and zeros equation, that is n is equal to z minus p. We have already discussed where z and p stands for the number of zeros and the poles including their multiplicatives, and the functions is inside is the fs contour. Now we will be satisfying the Nyquist criteria, and based on the Nyquist criteria we will be getting n is equal to z is equal to n plus p. That means zeros is equal to n, that is number of solutions you have, plus p is the poles. Okay, now here the basic example of the MATLAB code is the exercise number 1. Obtain the Nyquist plot of a system having a forward path transfer function. So the forward path transfer function here is given as gs is equal to 2s upon s plus 1 into s minus 1. So now here you can see that this is a second order transfer function, because I will be having an order is s square. Okay, it is s plus 1 s plus s minus 1. So it is a second order transfer function, that is gs is equal to 2s upon s plus 1 s minus 1, as you can see here. So let us go through the MATLAB code. Now as we have already earlier discussed, the first part of the MATLAB code is to have the numerators and denominator equation. Numerator, that is num represents the number of order of the zeros, that is numerators. Denominator represents the order of the coefficients on the denominator. So as we can see here, as it is gs is equal to 2 plus s, so what will be my coefficient? Coefficient of s is 1 and coefficient of s to the power 0 is 2. So my numerator is 1 and 2. In the denominator we are having two functions, one is s plus 1 and one is s minus 1. So there will be convolution of two particular numerator functions. The first numerator function will be that is 1, and that is 1 1 1, and second is 1 minus 1. So I am having a denominator is equal to convolution, conv is the convolution function of 1 1 1 1 means s plus 1, and in bracket comma semicolon in a bracket it is 1 minus 1 represents the that is s minus 1, and this bracket is closed. Please don't forget to apply here a semicolon at the end of the equation. Okay, please terminate every single equation with a semicolon at the end. Okay, so now after this I have to plot this transfer function, which is gs is equal to s plus 2 upon s plus 1 into s minus 1. So g is equal to tf is the transfer function command, numerator and denominator in the bracket, and with the semicolon I have ended up. Now in order to plot the Nyquist plot or the solution through the Nyquist plot, MATLAB control system toolbox is having this function which is my Nyquist, that is NYQUIST, 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 Nyquist of this transfer function g. So I have written NYQUIST Nyquist of bracket g. Okay, so this particular small code will execute the Nyquist plot for you. So what will be my output? As you can see here, there are two poles. One is at on the axis, this is -1, this is 0, and this is -2. So s plus 1 means I am having a pole at s minus 1. So this is a -1. I am having a pole at -1, and s plus 1 means s minus 1 means I am having a pole at +1. So here you have one pole here, and there is a 0 basically here. So this is my Nyquist plot for this particular function which you are having at the output. This is a Nyquist diagram. Now here are the arrows. You can see here I will be starting at this node, and from this node on anti-clockwise direction I will be having a circle here. Okay, because there will be only one particular complete solution of the circle, and it is on the left hand side of 0 axis. So it is a completely stable system which we have here. Okay, so I hope this code is useful. Now you have a simple assignment after this. Your assignment is to obtain the Nyquist plot of a system having a forward path transfer function of gs is equal to 1 upon s into s plus 1 into s plus 2. gs is equal to 1 upon s plus 1 into s plus 2. Okay, so hope this video is useful for